since you've heard from each of our panelists, maybe we'll start with some an opportunity for audience Q&A. Anyone with questions in our audience? We've got one here. Do we have a mic? Yes, it's coming your way.
So Alex, you may have had this in your slide, I just didn't see it. In your 30 cents per kilowatt cost projection, what did you assume for the cost of the methanol?
Around, of course it varies. We're looking at around $525, $550 US dollars per ton.
Per ton.
It's, around the world we see price fluctuation. That's U.S. price.
So are you assuming a low CI methanol or just a gray methanol
gray
for that?
Methanol.
In that price range?
In that price
okay.
range, yeah.
Any others? I think we've got one over there as well.
Are the containerized reformers capable of fast charging compared to grid construction?
Just a straight production model we're looking at, we don't believe it. Of course it can charge, but the time is most likely the problem. So that's why we see a combination with a battery pack with a high discharge rate. So if if the ferry only has a short time at the terminal, we can get a top-up charge in that time period.
If I could just add a little bit, so with the container, basically it puts out a constant power rate up to 300 kilowatts of energy, and then that supports a battery and charges the battery up, and so you get the fast discharge with the ferry, and then it spends its time, to recharge that battery. And so what that charge time is going to be is dependent on how many containers we're talking about, how big is the battery, how much power is going out to the ferry, et cetera.
Yeah, and that's not uncommon to the systems that are out today. I mean, today we have many applications where we're limited by what can be pulled off the grid because you hit those peak demand charges and then the cost of electricity goes through the roof. So Bruce and I see this more and more often where you're going to have shoreside energy storage if you're pulling off the grid or you utilize a container like this just because you need that fast charge in a lot of these applications.
The other thing, there was a comment in the slides, I'm not sure it was heard by the audience, is that where it can really add a lot of value is firm power, where there's just lack of grid power availability. So if you need power and you need to know it's always there, that's what this kind of solution do. And in fact, historically, where fuel cells have been deployed is when they're critical backup power applications where it can't break down. So a lot of government, a lot of telecom, because of the increased reliability that you get versus a diesel engine, which is what, 82% uptime typically, in the backup power scenarios, and fuel cells are closer to that 99.9 uptime reliability. And so it plays a part in that firm power, and that's probably the early adopters where they need guaranteed power is where they'll be placed.
Yeah, sorry, I do have to add something else to that. I mean, just last year, DOE came out with a huge grant. And what they were doing is they were changing all the telecom sites from diesel generators over to fuel cells. And because the reliability, I mean, anybody that's been in the inland business, when it seemed like every freaking time a chemical barge went into discharge, we couldn't get the diesel engine started because it sits around most of the time. So in these telecom applications, it sits around a lot. Yeah, they do go out and maintenance cycle it and so forth. But with a fuel cell or a system that generates the hydrogen right there, you don't have any moving parts. You just need to supply the hydrogen to it. And that's what DOE did just last year. It was several $100 million that they dumped into it to start changing this telecom over to make it more reliable than what they're doing today. So.
Great. Any others from the audience? Looks like we've got it.
There'll be 10.
And then how big is it?
Let's see, it's 3.5 cubic meters. What is it, Eric? 40 by 60 by 80 inches, right? Yeah.
And then the interchange, is it like changing an engine easy to come in and out? Do you have to?
Yeah, it's similar to that. I mean, part of the design, I would say, of the boat is to allow for that maintenance if it is required.
Yeah, and something that wasn't shown on the pictures that Mike put up here, there's hatches over top where they can easily be removed. One of the things that does add to the complexity a little bit, there is some purging of the lines, hydrogen and methanol, that you have to do in order to do maintenance. But other than that, they're essentially plug and play.
And there's a couple of data points here. So the hydrogen one is roughly 1.5 megawatts of energy, combination of battery, fuel cell, and hydrogen generators. And you've got 10 200 kilowatt fuel cells that are part of that, and then 10 of their M18 series hydrogen generators to support that. As we look to the future, perhaps in a year and a half, the sizing, the energy density of both the fuel cell and the hydrogen generator are increasing. So for that same amount of power output, the footprint of those components is going to be significantly less. So you could be going down to 6 or 7 of each of those components just based on the trend on both sides of the equation.
Any more audience Q&A?
I know the answer to this, but I think everybody probably would appreciate hearing. How often do you have to overhaul the reformer compared to a diesel engine?
So,
How often do you have to overhaul a reformer?
right, I'm going to there's two answers. I'm going to let ABB speak to the diesel side here, but for the hydrogen generator side, these are static chemical process systems. Essentially, you have a few air blowers in the front just to aid with air going into kind of our hot box, and a couple liquid feedstock pumps. Essentially, other than that, there are no moving parts. And so your maintenance is mostly just visual inspection and then changing out the filters for the methanol coming in to make sure there's no particulate going into the system. You're going to get in excess of 20,000 operational hours out of a system before you would do a rebuild of it. So that which similar to like a diesel rebuild. And so what does that mean? Well, that means more than 20,000 hours of producing hydrogen, which would be roughly 2.5 years, 24/7 operation before you do maintenance on it. And that would also be very similar to the fuel cell itself, that kind of an operational profile. And so if your vessel only operates where you're producing power a third of the time, then you can extend that time for major maintenance cycles for the fuel cell hydrogen generation technology.
Yeah, and a couple things to add there. One is we are staging these on and off as we need them. They're not continuously running. So that 20,000 hours, just like Robert said, it's 2.5 years. But now that since we're staging it, it's going to be further out than that itself. So, and then on the diesel side, of course, a lot of operators just look at how much fuel they burn. Very typical is a 3-year top end and a 5-year main overhaul, right? So we're already beyond that point of even needing to touch these things beyond what a top end typically is.
If I could expand on that. So there are 10 hydrogen generators on the hydrogen one. You saw the operational profile that Dave showed up in a slide where 85% of the time is less than 50% power. So that what that translates is, that towboat going through the water, there may only be 4 systems operating, producing hydrogen to support 4 fuel cells producing hydrogen. So the only ones getting hours are those 4 systems. The rest of them aren't getting hours. And so it's operated differently than internal combustion, where it's always on, it's always accumulating those hours. That's not necessarily the case in these modular type of power systems.
How's the weight compare to a gaseous hydrogen with heavy tanks and fuel cells going down the path of a hydrogen reformer or methanol reformer?
So if I'm understanding your question correctly, we're basically switching out the gaseous hydrogen storage for fuel reformer storage, correct? So from a CapEx standpoint, just the cost of the storage is going to be less for our technology versus the gaseous hydrogen storage. And so the CapEx is less. The hydrogen cylinders, there's a lot of dead space around it, so that's obviously not the case here. But the biggest impact is going to be on the OpEx, because we can produce hydrogen for roughly $4 a kilogram on board the boat. You can buy hydrogen if you're Amazon, you're a blue chip customer in Seattle, for roughly $12 a kilogram. And if you're a consumer in California, if trying to fill up your car, it's $16 to $22 a kilogram. You can do that for $4 on the boat. But more importantly, for the vessel operator, they have certain range expectations for that vessel. Whether it's a 3-day route, a 2-day route, or whatever, and you just can't get there with gaseous hydrogen without committing the entirety of the hold to carrying hydrogen, which means there's no business case for it. That answer your question?
I will let you go. This thing is like
The weight? Okay, I'm sorry. My apologies. So from a weight perspective, it is going to be comparable, I believe, based on the stat. I'd have to go back and take a look at that. So if you want to email me, I'd be happy to. Yep. Okay.
Well, I just have a question for a passenger vessel. If say you have passengers on there, you're doing a whale watch, right? And you don't have the diesel engines, you have the batteries, you have the reformers. Reformers charge the batteries while you're out on the water looking at the whales and cool.
Right. That's correct. That's right. No sound, very little noise, virtually no vibration. So for the passenger experience, it's going to be a much, you're going to hear the water against the bow is what you're going to hear.
When we get to where the whales are, we have to stay about 100 yards away from them. So we shut the power off, and then we drive a hydrophone in the water, and then we do them talk.
Yeah, I mean, the battery is going to be silent, of course, right? And so I think from for the experience you're trying to create, this type of power system should be very advantageous for you.
And no smell.
No smell.
And if you want to charge them at night, you have a container on the dock, and you do it from the dock just like you would shore power.
Right. So if this is an e-vessel, a battery vessel, correct. You could charge it either with the grid, or I think we're going to be competitive to grid pricing in certain scenarios, or many scenarios, and so you could charge it with the container.
Nothing volatile.
The methanol is treated just like you would gasoline, but it is in just about all the cases much safer. When a peach falls to the ground, it turns into methanol, and biology decomposes it, right? So if you have a spill with methanol water, there is an impact, but it's very short term because the biology in the water actually decomposes it rapidly.
I'm liking you guys.
We've got a couple others in front here. So, yeah, go ahead there.
So Robert, just to clarify, if you have a hydrogen generator on board providing power to the batteries, you're not going to have to hook the vessel up to charge at night. Is that correct?
Well, correct. We're combining a couple different scenarios here, but let me be clear. Our technology creates hydrogen from methanol water, and then we provide the hydrogen for a fuel cell system, which is someone else's technology to create it to power. So it can be everything from a range extender where the fuel cell and our technology is a minor part of the total power solution, but you're just looking for additional range to get through a shift. Let's say you wanted a 12-hour range, operational range with the battery because of weight or other considerations that can only get you to 8 or 10 hours. You could put our system on as a trickle charge to get that additional range, all the way up to what we're doing with Hydrogen 1, where it's the prime power. It's providing the base load for the propulsion, and the battery is actually more of a peak power. It's for the dynamic aspects of the ship's operation.
You don't intend to have to hook it up to shore power.
That is correct. That is correct. Yep.
So we do 2-hour dinner cruises, 2-hour whale watches, that kind of thing. So maybe a snorkel cruise, 4-hour. So just depending on what we need to do is how many batteries we need and how many reformers we have to have.
Correct. And so every application, part of when I mentioned, get together with your naval architect, your system integrator of choice, and let's talk about the application, because it all starts in kind of analyzing what your operational profile is, and it becomes either battery centric or fuel cell centric, and we figure it out.
Yeah, I think with Hydrogen 1, Austin's given me the opportunity to daily get the operational profile for his boats twice a day. And with that, we crunch all the numbers. To this point, I have about 13 months of data It's given every 30 seconds as to what power he's utilizing. I am a dorky engineer, but I'm not that dorky. I hate doing this stuff. But it is very essential to this, because we utilized that and said, okay, what is most of his power that he needs on this boat on a daily basis? And we used the reformers and fuel cells at that point to cover most of that time. And just like Robert said, we're using the batteries to peak shave, to boost, and then you can even sit in a fleet with this boat and just go essentially dead ship with the batteries by itself.
Yep.
But I think it's important to note with all that data that we've collected over the last year, the efficiency gains that we're able to make over a normal diesel engine. On the river, our boats, are more efficient than that normal engines above 50% of the profile. We looked at that time that that engine was actually over that, these boats run 24 hours a day. It's like 5%. So they're totally inefficient.
No, it's what, no, exactly, but what's amazing is a lot of operators haven't looked at that type of information. And so until we come in and we start saying, hey, let's look, and Ellie Beta is the same thing. Let's look and see how you operate your boat. And some operators come to me and they don't even know how to get it. So it's very important to start that conversation, to make sure these modular systems are designed correctly from the start versus putting something in and then hoping it works for your operation.
Can you go different propulsion systems rather than shaft and propeller?
Of course.
Go to jet drives?
Yep, any of the above. Yeah, they're going, it's L drive on the hydro one. Yeah.
By the way, I'd like 2 tickets, please. Is that
Robert, I think it's very important that you mention also the efficiency of the system, because having green fuel on board is important, but having less fuel, consuming less fuel is also very important. And our system is quite efficient. I think it's a very good point to elaborate a little bit more.
Yeah, so again, the system efficiency for both the fuel cell and our technology is much higher than what's traditionally out there. So typically, to get our overall system efficiency, you essentially multiply the fuel cell versus the hydrogen generator over some assumed operational profile. But you're going to typically find that combined efficiency is somewhere in the 45 to 50% overall system efficiency. Now, I know a lot of diesel gensets, they have a specified ideal efficiency that they can go to, but typically our efficiency curve goes down as you go into the lower power load of those systems, right? And it becomes less efficient at low loads and more efficient at the high loads. The fuel cell and our technology is almost the inverse of that. We are really highly efficient at partial loads, and our efficiency curve goes down a little bit. And so when I showed you that TCO model, and again, that's going to be unique for everybody. I'm kind of cherry picking some data to kind of prove the point. But your operational profile will drive what that curve looks like. This technology in the early days is more expensive than what you're used to paying with 140-year-old technology or 120 technology. However, we capture that back through operational efficiency through the OpEx side. And it's significant, right? And it just depends on how you operate and how close in that curve becomes.
Any others from the audience? I think we're kind of coming up on time for our the panel here, but anything that you guys would like to address that we've missed here?
I could actually answer that weight question, which I think is probably pretty interesting to everybody. The other weight question you had. So coincidentally, thank you. That'll help. Lee of ABB Design Group designed a pure hydrogen towboat, very similar in size to this boat. Before we even met E1, before we even knew, this was back in early 2021. For a customer that was interested in running it in the Bay Area for a very specific program. And that got proportionally bigger to a traditional towboat to go 55 nautical miles. That was the entire route of their trip because of the weight of the cylinders that we had to pack on to get that. In the almost exact same footprint, coincidentally, this is a bigger towboat. I know we're here to talk about ferries, but it all translates, right? The footprint is bigger because we're putting a ton of power into a relatively small, compact space. So it is bigger than a traditional towboat by a little bit, but it goes 550 nautical miles. So to answer your question,
the system overall is a lot lighter than if you were putting pure hydrogen directly, onto the boat and then into fuel cells. But it is certainly heavier than just a base diesel engine carrying diesel. Yeah. Yep.
Let me add one more point. I know the gentleman in the back asked how many reformers for the Hydrogen 1. It's a 1.2 megawatt boat. For smaller vessels, we have a smaller size reformer, and we're working on applications that are lower power, 60 to 100 kilowatts, that are using an array of the smaller version to accomplish what what we're doing with the Hydrogen 1. So I don't want you to think that the only solution is the larger unit. We have smaller units, and put into an array can satisfy smaller vessel needs.